We now look at energy. What is the energy of this mass or the spring? So when we have the spring in the equilibrium position and it's stationary, we apply a force, we pull it out up to here, we hold it here, and then we let it go. So as soon as we let it go, there is a force acting to the left, which will create an acceleration, and it starts moving to the left. So what is the energy at different points? Now at this location, it will have a potential energy, which is given, as we had already seen earlier, half kx square, and the spring would have a kinetic energy, which would be half mv square. So at this point, where the displacement is some value a, so it will oscillate between plus and minus a. This a is called the amplitude. At that point, its potential energy would be half k a square, and because it's stationary over here, the v is 0, therefore the kinetic energy will be 0. Now as it moves to the left, when it reaches this point, the x becomes 0, and so the potential energy here will become 0. So the potential energy will become 0 because x is 0, and the kinetic energy will have some value, half m some v square, as it's moving to the left. And then when it reaches the other extreme, and then it stops over here and then starts going backwards, then again at this position the ug will be half k a square, and the kinetic energy will again be 0. So as it goes from here to here, the potential energy was maximum, and then it starts decreasing to 0 over here, and then it starts again increasing. So what's happening is that this kinetic potential energy here is converting into kinetic energy here. So the potential energy converts into kinetic energy, and so these two should be equal. The kinetic energy here should be equal to the potential energy here. Now at any intermediate point, anywhere along the whole path, we should have a ug equals half kx square and a ke equals half mv at that position square. The total energy at that point would be the sum of the two, and that should be equal to half k at that position square plus half m, the velocity at that position squared. Now because all of this energy here, which is partially kinetic and partially potential, has to come from this initially, so therefore this should equals half k a square. So this is the maximum potential energy. As it goes down, the potential energy converts into kinetic energy. The potential energy gets smaller, the kinetic energy gets bigger. When it reaches the middle, this goes down to 0, and this would become equal to the total. And then as it goes here, again, the potential energy increases and the kinetic energy decreases. So if we draw right under here, this is our x equal to 0, and these are the two extremes. And if we draw the energy here, the total, let's first draw the potential energy, which is half kx square. So when x is maximum, the potential energy is, let's say, this value, that's ug, and in the middle the ug right here should be 0, and then when it's on the left extreme it should be the same, and it's x square, so it's a quadratic, so we get a quadratic curve that goes like this. Now the kinetic energy here is 0, so I draw that with the red color, so the k is 0 and the k is 0 here. And because the sum of the two must always be the same, so when this is 0, the kinetic will be equal to this potential energy, so it should be right here. this would be the maximum kinetic energy, and then this should be the same value. And this is also a quadratic, so it should follow a curve like this. So the potential kinetic energy is maximum here and 0 at the two ends, and the potential energy follows this curve. If we add these two together, they should equal the same value. So if we use this as the sum of the two, this will be the Ke plus Ug, and that will always be equal to half Ka square. So it's a case of conversion continuously from kinetic energy to potential energy. Now if we look at this equation a little bit more, and we write, we want to find the velocity from this equation, we can say half mv square equals half Ka square, and we bring this on the other side, half Kx square. We can cancel out the half, and we divide everything with m, so v square becomes equal to k over m, and well, we have the same thing here, so we can take it out, a square minus x square, and therefore the velocity at any point is plus minus square root k over m, which we can write as an omega square root, but we can just leave it as k over m, and a square minus x square. So that becomes an equation for the kinetic energy, for the velocity. Now let's do an example on this.